Happy Monday. So this section is 5.6, derivatives of inverse trig functions. And I'm on page 369. If this screenshot is difficult to see, because I've done a lot of scribbling on it, these are the 6 derivatives that we'll be working on today. And we are just going to see how they work. So we're going to find the derivative of inverse trig functions. So you might remember from last year, we could either talk about sine to the negative 1 of x or arc sine of x. And both of those mean the inverse function of sine. So we're going to learn how to find their derivatives. And then these will be the last derivatives, I believe, that we will learn this year. So here they are. And we'll talk about what they mean. So pause if you want and go ahead and get these written down. Okay, so if you've got them written down, or you're going to look back at them, let's do example 4 together. I'm just going to see how these things work. A part. Let's find the derivative of the arc sine of 2x with respect to x. Okay, so looking back at the formula for the derivative of the arc sine of u on the other page, it is u prime over the square root of 1 minus u squared. Excuse me. So that's our formula. So all we're going to do, well, to find the derivative of the arc sine of u, if these things match that we're taking the derivative of, it means u is 2x. Now, we don't do du and make things match when we do a derivative. We just do a little u substitution. So we know what u is. So now we can go and we can fill in this part of the formula. U prime would just be 2. So that's the numerator, over the square root of 1 minus, this is our u, the 2x squared. And we would just clean it up just a tiny bit and call that the square root of 1 minus 4x squared. And you could have squared this before you put it into your formula. All right, let's do B part. So they are kind of straightforward today. There are a few that get a little wonky in your homework, but we're mostly just trying to learn how these formulas work. Whoops, this is arctangent for B part. Arctan of 3x with respect to x. Well, the arctan formula says arctan of u, so this is our u, is u prime. Let me double check it. U prime, so 3 over 1 plus u squared. And that's it. All right, C part. Let's do the derivative of arc sine of the square root of x with respect to x. Well, we just did this a second ago. U is the square root of x. Written friendlier, that's x to the 1/2. So u prime on the numerator is 1/2 x to the negative 1/2 over the square root of 1 minus u, which is square root of x squared. So when you square the square root of x, you just get x. Now the only thing we need to do is we're going to rewrite this 1/2. Let's just rewrite the numerator. It would become this, right? Now, if I were to take this, put it over 1 so I can flip it and multiply, it would also be in the denominator. So it would be 1 over 2 square root of x, square root of 1 minus x. Oh, and we can distribute across those square roots. So let's call that we'll call that 1 over 2 square root of x minus x squared. And that is that. That part bothered you, multiplying under those square roots. Just remember that you can do like square root of 3 times square root of 4. Oops. And call that the square root of 12. It's fine to put both of those under the same root and multiply. So that's all we did. We sort of moved that one under the root with the other, and we just distributed. Okay. D part. We have the derivative of the arcsecant of e to the 2x dx. Arcsecant is a little bit more complicated. If you're looking on page 369, is arcsecant one? Oh, arcsecant's formula was okay. The first one on the left at the bottom, but then they've got a typo. They say that last one that they give you is also arcsecant, but that's arccosecant. Let me go back. And I have a little typo myself. That's a C, S, C. So this is the derivative of arcsecant rule, not secant. Okay, so arcsecant is, arccosecant's rule, not arcsecant. I'm not sure if I said that right or not. So we are going to fill into this formula. This is our u. So the derivative would be u prime. So that'd be a little chain rule, because the derivative of e to the u is e to the u times u prime, e to the 2x times 2, over absolute value of u, so e to the 2x in the absolute value bars, square root of u squared, so we're going to square that, so e to the 2x squared minus 1. I'm not sure where I paused the recording. I may have originally paused it to discuss why multiplying these became this, and I came over here and did this, and then I said, remember how you can take those two square roots, put them under the same root, and multiply and get 12. So that's all we did here. We just put both of those things under the same root and distributed. And then I set up arcsecant, and I said on page 369, that picture that I pointed you to had a typo. This is the correct derivative of arcsecant. This is not arcsecant, it's arccosecant. So I'm not sure where I hit pause. But here we're ready to take the derivative of arcsecant and use e to the 2x. So it's u prime over square root of u, absolute value of u, and then square root of u squared minus 1. So the derivative of this is a chain rule, e to the 2x times 2, over the square root of the e to the 2x. I keep saying square root. I've moved my daughter this weekend, and I'm pretty tired. I meant absolute value, and then the square root of u squared, so we had e to the 2x squared minus 1. So that numerator is 2e to the 2x. Let's discuss this for a second. Are there any values that x could take on that would cause what's in the absolute value bars to be negative? Well, what if x was a negative number, like -3? Well, that would say that it was e to the -6. But doesn't make e negative, it just means it's 1 over e to the 6th. E is still 2.718 approximately, so it's still a positive number. That negative power just flipped it, so we don't need the absolute value bars. And then e to the 2x squared is e to the 4x minus 1. And then we're allowed to bring that under the root. Well, no, let's don't even worry about bringing it under the root. Let's just divide it out right there. So that's 2 over the square root of e to the 4x minus 1. All right. This example 5, I think it's a little bit wild, but let's work through it together. Let's do y equals arc sine x plus x square root 1 minus x squared. They want us to find the derivative. So, derivative of the arc sine of x is what we've been working on, where u is x. So that's u prime over the square root of 1 minus u squared plus, this is a product, so we have to do product rule. So I want to rewrite that second factor a little nicer so we can do product rule. Or you could move that, they don't usually do that. Let's just do product rule. First times the derivative of the second, let's do chain rule. Plus second times the derivative of the first. First times the derivative of the second, that's all of that, plus second times the derivative of the first. Okay, so we'll leave this first term alone for now. Let's rewrite this second term. We have a half of 2, so those numbers are gone. And we have an x times an x. If you just look, everything is being multiplied. Multiplied by multiplied by multiplied by multiplied. So we can reduce anything that we're able to. So that's going to leave us with a negative x squared in the top. And the denominator is 1 minus x squared. So that's interesting. We're going to have a common denominator. Plus the square root of 1 minus x squared in the numerator. So all we need to do in order to get a common denominator is multiply this last fraction by the denominator everybody has. And we have to be fair and do the top and the bottom. So now everyone has the common denominator. So we're just going to put the numerators together. What is this multiplied by that? What's something to the half power times another something to the half power? Multiply like bases, you add exponents. So it's to the first power now. So we have just plain old 1 minus x squared all over. And that shouldn't be a minus, it's a plus there. All over the square root of 1 minus x squared. When you combine like terms, you get a 2 in the top, and your x squares do not cancel, do they? 2 minus 2x squared over the square root of 1 minus x squared. Well, if we factor a 2 out now, that is a 1 minus x squared in the top and a 1 minus x squared to the 1/2 in the bottom. So what happens when we divide like bases? This one has a power of 1, and that's got a power of a half. When you divide like bases, you subtract to keep the, and so 1 minus a half is a half. And that's our answer. It wasn't terrible. I'm sorry if I jumbled it, just because I'm a little sleepy. Example 6 is kind of interesting because it makes you look at a graph and think about points of inflection. Example 7 is really quite interesting, but I'm not going to go over it today. This is going to be it for us today.